Good evening, everyone. Let us start today's session. Let me share my screen. Is my screen visible? Okay. So today we are here for our for the fifth week of our tutorial on the course Petroleum Technology. So in this week, we will be talking about the various products from the crude oil, various distillation fractions that we get from the crude oil. So the first product that we get from the crude oil is the liquefied petroleum gas, that is LPG. Uh, LPG, we all know that it is basically used in the households for the for cooking purpose. Uh, Cooking purpose, but not on, but that is not the only application of LPG. It is used in various other applications also. LPG, it is the lightest fraction that we get from the crude oil, that we get from the overhead of the atmospheric distillation unit. So LPG, it is both environmentally and ecologically friendly and is considered one of the world's most important fuels. The biggest advantage of LPG over natural gas is that it can be easily converted into liquefied state and which becomes easier for its storage purpose. Why so? Because the natural gas, it is a just a second. The biggest advantage of LPG over natural gas is this natural gas, it is C1 to C4 cuts. So this natural gas, it consists of mainly methane, which is a very smaller molecule compared to, and this LPG, it is C3 and C4 cuts. So this methane, it has very lower boiling point, due to which it becomes very difficult to liquefy this methane gas and store this natural gas compared to LPG. Whereas this LPG, which consists of C3 and C4 cuts, which has higher boiling point compared to methane, due to which it becomes easier for the it becomes very easier. The liquefaction of this LPG becomes easier in comparison to this natural gas. That becomes its biggest advantage. Therefore, it has the benefit of portability in terms of liquid, but this LPG, it becomes easier to store and to transport it from one location to another in with respect to natural gas. Though the calorific value of natural gas is more than LPG, but due to the this portability and handling issues of natural gas, LPG is considered more important fuel compared to this natural gas. The main constituents of LPG is, as I told, it is C3 and C4 cuts. So this propane and propylene, it is from the C3 cut, and N-butane, isobutane, and butylene, this is from the C4 cut. And in some cases, it may also contain some of the C2 cuts, which are the lighter cuts, and some of the heavier cuts of that is of C5 cut, that is pentane and pentene. The straight distillation process generally result these during the extraction of LPG. It is, as I told, it is the lightest cut that is extracted from the crude oil. So it is extracted from the overheads of the atmospheric distillation unit. So during that straight distillation process, which results in saturated production of saturated hydrocarbons, whereas the distillation process, they mainly yield saturated hydrocarbons, whereas the secondary processes which we studied earlier, the thermal cracking, catalytic cracking, then reforming, hydrocracking, they yield in unsaturated hydrocarbons. Basically, what we are trying to say here is that in the distillation procedures, that is the vacuum distillation and atmospheric distillation, we get mainly saturated hydrocarbons, whereas the olefinic compounds, that is double bond compounds and these cyclic compounds, they are mainly we get it from the secondary processes such as cracking and reforming procedures. Okay. So source of LPG, coming on to the source of LPG, the prime source of LPG, it is there are two sources of LPG. The one is from natural gas and other is from the crude oil. So we can get LPG from two sources. One is the dry source and other is the wet source. Dry source is from the natural gas reserves and wet source is the from the crude oil. Okay, just a second. Someone is trying to join. This LPG has to be separated along with any naphtha. During the distillation procedure from the crude oil, as I told, from the overheads we get LPG, and the cut after LPG is the naphtha. So there may be sometimes a mixture of naphtha and LPG also separated out. It is very difficult to separate two cuts completely from each other. So if there is some amount of naphtha also present in LPG, that needs to be separated. So there are two sources of LPG, that is, as I told, the natural gas and oil and crude oil. So the natural gas fields, the dry field, which is natural gas fields, may also contain substantial quantity of LPG associated with the natural gas. It may be, and sometimes when we can also get LPG if liquefied natural gas, it is regasified again, then also some amount of LPG we can extract from liquefied natural gas. Okay, so refinery operations provide a large amount of these refinery operations. They provide a large amount of LPG from the refinery gases, that is the overhead from the atmospheric distillation unit. We can get LPG. Then debutanizer tower, which is also present in the overhead section of the atmospheric distillation unit itself. There also in the debutanizer tower, where butane is stripped out from the naphtha section, there we can get LPG. Then catalytic reforming unit also we can get LPG. In catalytic cracker and visbreaking breaking unit also we can get LPG. So these both above, they are extracted from the primary extraction methods, that is from the distillation. And these three, catalytic reforming, catalytic cracking, and visbreaking, they are from the secondary extraction methods. Coming on to the characterization of LPG. So LPG, it is basically depending on the different standards set by the Bureau of Indian Standards. They are of three types. One is the commercial butane, one is the mixture of butane and propane, and the third one is commercial propane. So, as we know, propane, it is a smaller molecule compared to butane. It has lower boiling point, and so its storage pressure is very higher compared to butane. So, the storage vessels for storing propane is the standards for storage vessels for storing propane is quite different compared to butane. The storage of butane, it is not a problem, since it does not impose much more pressure. It does not impose the higher pressure, whereas propane, its storage pressure is very high. That's why the storage vessels for storing of propane, it is a special kind of vessel. We can store butane in the storage vessel of propane, but we cannot store propane in storage vessel of butane. So consequently, commercial propane cylinders should never be stored or used inside residential premises. Due to this high storage pressure, the propane cylinders, they should not be stored in residential areas for safety purpose. Commercial butane is exclusively used in cylinders for its portability, whereas this commercial butane, it is quite safer compared to propane. So it can be easily stored in a cylinder and it can be easily transported from one place to another. Coming on to the applications of LPG, as I told, the most common application of LPG that a layman knows, it is used as domestic fuel in cooking, gas-fired central heating, and hot water systems. And then in the industrial fuel, it is used for the heating of water for generation of steam, then bitumen heating and roofing, then oxypropane heating and cutting. Mean high energy that oxypropane flame for cutting also which is used for cutting of metals, etc. There also this LPG is used. Then it can also be replaced as automotive fuel. Then in agriculture for grain and grain drying, flame cultivation and wheat burning, LPG is used. And specialized applications, sometimes it is used as propellant in aerosol markets and replacement in refrigerants for ozone replacement of it can also be used as a replacement for CFC, that is chlorofluorocarbon, and HFC, that is hydrofluorocarbon, which are the oxygen depleting chemicals. It can also be used as a replacement for these chemicals in refrigerants. We can also replace them on LPG. Coming on to the purification processes of LPG. LPG stream from refinery processes. As I told that this crude oil consists of various contaminants such as sulfur, nitrogen, and some traces of metals also. So similarly, this LPG that is extracted from this crude oil will also consist some traces of these impurities. So the LPG stream from refinery, which we produce from the refinery, it is sour as I told in that the presence of hydrogen sulfide is there in that uh, crude oil or the distillate fraction. So it contains H2S, then alkyl mercaptans, traces of organic sulfides and disulfides. So the removal of these impurities needs to be done, which is done using various procedures such as caustic wash, then Marox treatment, then amine wash, odorization, and and moreover, as LPG is almost odorless in its natural and refined state, so for the safety purpose to detect the leakage of LPG, sometimes alkyl mercaptides are also from, are added to this LPG to provide it a specific smell so that if there is a leakage of LPG, it can be easily detected for safety purpose. Okay. Coming on to the safety concerns related to LPG. The knowledge of vapor pressure of LPG is essential to specify the design conditions of pressurized system. In the vapor pressure of LPG should be known so that it can be so that the design of the vessel to store this LPG can be easily determined. The pressure exerted by butane is considerably lower. As I told that the pressure exerted by butane, it is lower compared to propane. Hence, container designed for butane are unsuitable. We cannot store propane in a container that is designed for storing butane. Whereas vice versa is possible. You can store butane in a propane container, but you cannot store propane in a butane container. Okay. Propane designed vessel may be used to store any of the products. LPG containers are normally protected by the safety relief valves. They are designed to protect the system against any overpressure and are safe to discharge at a preset pressure. Mixture of LPG and air is flammable between specific concentrations known as the flammable range. And the mixture of LPG with air, it is flammable at after between a specific concentration. So that specific concentration that ranges from for butane it is 1.8 to 9%, and for propane it is 2.2 to 10%. If the mixture of if this percentage of butane or propane forms a mixture with air, it can cause fire hazards. So but outside this limit, LPG will not burn. So this is called its flammability range. Now next cut, which is the next heavier cut after LPG, which is extracted from the crude oil, it is naphtha. It consists of C1 to C1 fractions, that to C1 fractions to 180 degrees C. So it is It consists of some amount of C1 and C2 gaseous product, then C3, some amount of LPG is also present in naphtha fraction, then C4 fractions for LPG. C4 fraction of this naphtha is used for LPG and for gasoline blending. Then C5 and C6 fraction is a virgin light straight run naphtha, which is extracted from the side cuts of atmospheric distillation unit. And the C7 cut, which is used as a feedstock for catalytic reforming. Okay. So these are the streams that arises from crude oil fraction, crude oil fractionation that is in the atmospheric distillation unit, and then catalytic reforming. Also, we can get naphtha and from distillate hydrocracking. Butane stream of octane. Butane stream of octane number close to 100, but high RBP is a gasoline blending component. Hmm. This naphtha is used in various. These naphtha cuts are these different naphtha cuts are used in different applications. As I told here, the C3 and C4 cut is used as LPG, and then C4 C5 cut. The C4 cut is also used for gasoline blending. Gasoline blending is basically to enhance the quality of gasoline. Okay. So here it is told that the butane stream obtained from this naphtha fraction, it is used for blending with gasoline to improve its quality, and it is almost very small amount. That is only 5-8% of butane is used for gasoline blending. Surplus butane may be used in combustion with and the remaining means some amount of butane is also used as in combination with propane as LPG. As I told earlier, that LPG it is a mixture of C3 and C4. The isobutane component of the butane stream is a necessary feedstock for the alkylation unit. Then virgin light straight run naphtha may be absorbed directly into the gasoline pool if its octane quality permits. This C5 and C6 cut it is also used as it is also used in gasoline blending pool to enhance its octane number. More often, light straight run naphtha has to be isomerized first. A large portion of light straight run naphtha is disposed to petrochemical production. A large amount of light straight run naphtha is given off to the petrochemical production, either for aromatic production or for steam cracking for ethylene and propylene production. Okay. So these are the basic applications of naphtha. Then C5, C6 fraction is isopentane, a hydrocarbon, isopentane. This C5 and C6 fraction, which is isopentane, it is also used as a component of aviation gasoline. And catalytic reformer feed has to be hydrotreated for catalyst protection. This C7 fraction, it needs to be hydrotreated for the in the catalytic reforming unit it is used. So here for to prevent the deactivation of the catalyst, we sometimes it has to be it is hydrotreated. Coming on to the gasoline characteristics and properties, these are some of the characteristics and requirements of gasoline. The gasoline it should burn smoothly without knock. As I told that as we studied earlier, the octane number it is a very important property of gasoline. So the gasoline it should burn in the engine without any knocking. So that means it should have a good octane number, and it should not it should not cause any thrust over the engine, and should have anti-knocking properties. It should be sufficiently volatile to give a flammable mixture under all operative conditions. As we studied earlier, that the gasoline, when come in forming a mixture with air in the engine, in it burns. It burns. So it at all conditions, this gasoline should be sufficiently volatile to produce sufficient amount of vapors. That vapors, when it forms mixture with the air, It burns with, it burns uh, I it burns with, it forms a flammable mixture. Uh, Give good fuel economy, lead to minimal emissions. That means it should not consist of impurities or impurities such as sulfur impurities, which may form sulfur dioxide, or some amount or nitrogen impurities or metal traces. So that during its combustion, it should not release. It should not release. It should. It should release minimum emissions. It should not form deposits in the engine, as told earlier that the gasoline it may form. It is stored in a floating head storage vessel. So coming in contact with the atmospheric oxygen, it forms gums. So these gums can clog the engine and can also lead to the corrosion of the engine. So it should not also these presence of gum should not be there in the engine, should not be there in the gasoline. It should not degrade, not degrade the performance of emission control system. So each engine it consists of some kind of emission control system. So when this gasoline it burns in the engine at it and flue gases are emitted out of the engine. So these emission control systems, if there are presence of some amount of SO2 or NO2, these gases are present. These emission control systems they convert this into less harmful gases. So, if the traces of some kind of octane enhancers, that is, as we told earlier, as we studied earlier, some lead based, if some lead based octane enhancers are present in the gasoline, then these can these lead-based octane enhancers they deactivate the catalyst present in these emission control systems and may degrade the performance of these emission control systems. So chemicals should not be present in the such additives should not be present in the gasoline. So be handled acceptably at all stages from the refinery, and it should be easy handling of gasoline from the refinery to the fuel tank should be done. Proper handling should be done. It should not be like it has very high volatility and it gets evaporated from the refinery to the fuel tank. So it should not happen. Coming on to the natural constituents of what are the natural composition of gasoline. So it consists of hydrocarbon parts of gasoline. It consists of alkanes, aromatics, and alkenes. But these alkenes with lesser amount of cyclic alkanes and cyclic alkenes and up to C12 comes. Trace amount of non-hydrocarbon parts are also present. Sometimes oxygen, some amount of nitrogen and sulfur may be present in the gasoline. And along with that, some different additives and blending agents are used in the gasoline to improve its quality. So, various blending components are added to the gasoline for different commercial and environmental reasons. So, mostly, initially, we studied that lead based octane enhancers were used, but due to its toxicity, now these lead-based octane enhancers are replaced with oxygenates such as some light alcohols and ethers are added in the gasoline to improve its octane number. To eliminate these lead-based toxicity in the gasoline, the ethers have excellent octane blending characteristics. Uh, mean uh, These ethers, basically methyl tertiary ether, these are used as the octane enhancers in the gasoline. And sometimes to improve the volatility of gasoline, also some amount of alcohol is added. For example, in some colder regions, the gasoline inside the engine it does not form proper. Does it has it becomes it does not form proper vapors to form a mixture with air and combust inside the engine. So in that cases, some amount of ethanol or different alcohols are used to provide initial volatility to the gasoline for proper combustion of the gasoline inside the engine. Okay. So C1 to C4 alcohols are also used as gasoline replacements for or extenders. some objectionable components which are present, which are which should not be present in the gasoline. So basically, first one is benzene. It is an individual hydrocarbon in gasoline. Why benzene is highly restricted because of its carcinogenic nature. Benzene is highly restricted in various countries. Then aromatic content of gasoline should be kept below 30 to 50 volume percent, because 30 to 50 percent. Why so? Because during combustion it may generate some amount of benzene, which, as I told, it is carcinogenic in nature. Then some metal contents, they should be avoided, as I told, that lead, mainly lead, which was initially used as lead based octane enhancers were used initially, but now due to their toxicity and the ability of this lead to deactivate the catalyst used in the to deactivate the catalyst used in the in the catalytic converters, where these emission gases, harmful emission gases, where they are broken down into less harmful components. This lead may deactivate the catalyst converter in that system. So for that purpose, the lead content should be minimized as much as possible. Then sulfur content, it should be controlled, because after the combustion, if there is large amount of sulfur present in the gasoline, then and it may, in the flue gases, there will be large amount of harmful gases such as sulfur dioxide. So and sulfur dioxide may be emitted into the air, and moreover there odor of certain sulfur compound, it is very it is very obnoxious smell, and to enhance its storage stability also. So we need to minimize the sulfur content in the gasoline as much as possible. Now coming on to the middle distillates, they are basically the distillate content which comes after gasoline. So firstly, it is LPG, which is given as overhead. Then it is naphtha. Then after that, it is gasoline, and then this comes there kerosene and diesel. So this kerosene and diesel cut is collectively called the middle distillate. Kerosene and gas oil, diesel oil is also called gas oil, are names given to various middle distillate fractions withdrawn from an atmospheric distillation unit in the boiling range of 150 to 350 degrees C. So this kerosene is from 150 to 250 degrees C, and this diesel is from 250 to 350 degrees C. There is always an overlap in boiling range and composition between diesel and kerosene. So prominent among the finished kerosene and gas oil products, prominent products, just a second. Prominent products, prominent among the finished kerosene and gas oil products, the prominent, these kerosene and gas oil, which is mainly used, they are mainly used in as aviation turbine fuels and automotive gas oil distillate, automotive gas oil, or that is the diesel oil. So most jet fuels originate from straight run atmospheric distillation column, and a little extent this jet fuels, this aviation turbine fuels, mostly they are mostly they are originated from the straight run atmospheric distillation column, which is kerosene. High grade kerosene is used as taken as ATF, that is aviation turbine fuel, and a small extent is also taken from the hydrocracking unit. Coming on to the jet fuel, it is a potential fuel for the gas turbine engine. Crude feedstock selection is an important quality criteria for jet fuel production. Crudes having the jet fuel, it should have higher linear and branch crudes having higher linear and branch paraffin contents are preferred to those which are high in naphthenes and aromatics. Mean naphthenes and aromatics they are not preferred. Crude oils having higher linear and branch paraffin contents are preferable for using as jet fuel. The boiling range it varies from 150 to 270 degrees C, and all jet fuels are composed primarily of hydrocarbons as a blend of saturates with no more than 20 to 25% aromatics. As we told that aromatics are less required, so only 20 to 25% of aromatics are acceptable in case of jet fuel. Olefins may be present, but they are effectively kept below 1 to 5% for stability purpose. Okay. These are some of the additives which are used in the jet fuel to improve its quality. That is the oxidation inhibitors. That is to prevent gum formation because this jet fuel when it comes in contact with the atmospheric air, it forms resinous compounds which are called gums, and which are formed due to the formation of peroxide, which hydrogen peroxide, which in turn and which act as an oxidizing agent and promotes the oxidation of the promotes the oxidation of the crude oil. Therefore, over these oxidation inhibitors, it retards the formation of peroxide, thus in turn reduces the oxidation of the crude oil. The metal deactivators to remove by chelation any dissolved copper to prevent catalyst of oxidation reaction. Okay. Then anti-icing agents, if there is, as I told, this jet fuel, they consist of higher linear and branch paraffin. So high linear paraffins, as I told, is a composition of waxes. Mostly, if there are large if there are long chain paraffins present in the crude oil, then then there is the presence of large amount of waxes. So at lower temperature these waxes may these waxes may form crystals, and disrupt the flow of the fuel. Therefore, and moreover, and another thing is some amount of if there is some amount of dissolved water present in the jet fuel. Yes, okay. Please join the class on time from next time. So these anti-icing additives are used if there is some amount of dissolved water present in the fuel. It may freeze at lower temperatures. So therefore, which may further create create problem in the combustion of the jet fuel, and also may combustion of the jet fuel. Therefore, to prevent the freezing of the dissolved water, anti-icing additives are used, and then corrosion inhibitors are used essentially for distribution pipeline protection and exhibit beneficial properties with respect to fuel lubricity. Mean if there are some amount of corrosion, means some traces of metals or such impurities are present which may cause corrosion in the storage vessel or distribution pipeline. For that purpose, corrosion inhibitors are added into the jet fuel. The next is the automotive gas oil, which is the diesel fuel. Automotive gas oil is the name given to the fuel intended for use in road vehicles such as the trucks, buses, vans, and cars, which are powered by diesel engine. Okay, the fuel is obtained from distillation and processing of crude oil in the boiling range. Its boiling range is 200 to 350 degrees C. And the basic requirements for diesel fuel is ignites continuously when injected into the combustion chamber. So this is the diesel fuel, as we have discussed earlier, that there is this delay period in the diesel engine, delay of in the diesel engine from the injection time to the combustion time. So that delay period should be as low as possible. If that delay period extends, that may cause knocking in the engine, and therefore this delay period should be as low as possible, and and the diesel fuel should ignite continuously and smoothly, for which cetane number of the diesel fuel should be high. It burns cleanly, quietly, and economically in the engine, does not degrade the efficiency of any exhaust after treatment device. As similarly as told in the gasoline region, after the combustion, the flue gases are ejected from the engine, and for that purpose, some exhaust after treatment is done, so that the harmful gases should not emit directly into the air. For that, some after treatment devices are available in the engine. So, if some impurities are present in the diesel fuel, that may deactivate the catalyst used in the after treatment devices. So, they should not be present in the diesel fuel. Can be handled safely and conveniently during distribution, and does not contain contaminants or separated wax. Separated wax, as I told, the diesel fuel, it uh, mean high should have high cetane number, and for high cetane number, it should have long chain paraffins. As I told, that the presence of long chain paraffins gives better cetane number to a diesel fuel. But if long chain paraffins are present in the fuel oil, then the wax content automatically increases in the fuel oil, which may create problems during transportation of this diesel fuel from a hotter area to a mm, uh, colder region, because the this wax present in the diesel fuel, it will start to freeze and form crystals, due to which the flowing ability of the diesel fuel it ceases. Coming on to the composition of diesel fuel, it is composed of 75% saturated hydrocarbons, primarily paraffins, including an iso and cycloparaffins, and 25% aromatic hydrocarbons, including naphthalene and alkyl benzenes. So the average chemical formula for common diesel is C1223, C12H23, ranging approximately from C10 to C15. Okay. Contaminants to diesel fuel: water contamination can result from, there can be some water contamination from the rain leaking into the storage tanks, or contamination during shipping, or condensation from humid air in the storage tank, or the sediments consist of solid contaminants such as rust from the fuel tank and lines, dirt and particulates from air, and organic deposits from fuel. Coming on to the properties which are required in the diesel fuel. So good volatility should be there. Fuel volatility has a major effect on engine performance. The volatility of is measured by plotting a distillation curve, that is the ASTM D86 curve of and it should have and the diesel fuel, it should have good volatility, show that, as I told, that the diesel fuel will should the diesel vapor, along with the mixture with water, along with the mixture with air, or combust in the diesel engine. So if there is not a sufficient volatility of the diesel fuel, then the vapors will not be generated, and there will be no combustion inside the diesel engine. Okay. So the cetane number of diesel, it is a measure of ignition quality and has a major influence on engine performance. As I told, that the cetane number should be high. Okay, what is that? That is that the delay time from the ignition to the combustion of the diesel fuel inside a diesel engine should be as low as possible for the smooth running of the diesel engine. Then cold flow performance. The diesel, uh, as told here, that it consists of 75% saturated hydrocarbons, that is the long chain paraffins. So if there are major component of the diesel fuel is and paraffins, then it has huge wax content present in them. So at low temperature, what happens is the wax content of this diesel fuel, it starts to freeze, and it starts to form crystals and freeze, due to which the transport of this diesel fuel from hotter region to colder region becomes a problem. That's why sometimes 4-point depressants are also used to further lower the 4 point of the diesel fuel so that easy transportation of diesel fuel can take place. Then the carbon residue is a measure of the buildup of carbon deposits in an engine, and hence diesel fuel specification include a limit on carbon residue. I mean, carbon residue, as I told that during the combustion of a diesel fuel, after the combustion, the diesel fuel may leave some amount of carbon residue. So this carbon residue, it should not, there should be no buildup of carbon residue on the engine, and otherwise the performance of the engine will be restricted. Then the sulfur content of the diesel fuel should also be low. Otherwise, after the combustion, the emission gases will consist of harmful gases such as sulfur dioxide, and obnoxious sulfur compound smell will be present. Therefore, to reduce that, sulfur content should also be limited. Coming on to the automotive gas oil additives. To make fuel fit for purpose and conform to local specifications, some additives are added. Some amount of additives are added to improve its quality as well as to improve its properties and qualities, its combustion quality, as well as to improve the flow and to reduce the corrosion and rusting inside the engine. Some additives are added. So main additives are the cetane enhancers to reduce the delay period of injection to combustion. Some cetane enhancers are added. Then anti-foaming agents are also added to prevent the formation of foam during the transfer of diesel oil that inside the engine. Sorry, inside the storage tank of the vehicle. Then the corrosion inhibitors to prevent corrosion of the engine due to the formation of gums or some acid formation. Then flow improvers uh, uh, to prevent the formation of wax inside the diesel fuel and to improve its flowability from a hot region to cold region. Then antioxidants and stabilizers to prevent the oxidation and to provide us oxidation stability to the to the gas oil. Some antioxidants and stabilizers are also added. Then coming on to the next, which is the fuel oil. Fuel oil is it is the distillate fraction after after the middle distillate, that is after the diesel oil. That side fraction is the fuel oil, which is it is made from the residues remaining from atmospheric and vacuum distillation. It is the heavier residue which is above the atmospheric residue and vacuum residue. The last the end product is the atmospheric residue and vacuum residue, but this above that is given above that the distillate cut given out is fuel oil. So it may be given from the residue from the atmospheric and vacuum distillation unit and the conversion processes after the removal of lighter hydrocarbons. So production of residual fuel makes it necessary to blend the heavier. These are the this fuel oil. It is the residual fuel which is very heavy. It is the heaviest cut from the vacuum distillation unit or visbreaker residue. So sometimes some lighter cuts are blended along with it to improve its quality. Which light ends are the gas oil or light cycle oil. This gas oil is the last second cut from the atmospheric distillation unit, and the light cycle oil is the side cut from the vacuum distillation unit. This is from the atmospheric distillation unit, and this is from the vacuum distillation unit. So these lighter cuts are blended with this residual fuel, this heaviest cut from the vacuum distillation unit or visbreaker residue and catalytic cracker, slurry oil or asphalt with lighter cuts. So this heavier residual fuel, it is blended with gas oil and light cycle oil to improve its quality and used. And this blended oil is collectively this residual oil plus these both are collectively called cutter stock. So this residual oil and plus this cutter stock, it is mostly taken in the 70 to 30 ratio. This is called as fuel oil. There are two general kind of fuel oils. They are general uses of fuel oil. They are mainly used in burners and engines. Important physical and chemical properties of fuel oil are the viscosity and viscosity temperature relationship. So in burners and engines, this fuel oil is used in burners or engines. So the important property, viscosity temperature relationship is a very important property. That is, the viscosity index should be high. That means as it is heavier residue, so it is more viscous compared to the lighter cuts. And if it is used in engines and in burners, it should have a high viscosity index. That is, the with change in temperature, the viscosity should not show much change in its properties. Okay, in its flow, in its viscosity properties. Then pour point is an important property for. When flowing from a hotter region to colder region, it should not freeze. That is, the presence of wax content should be lesser in the fuel oil, and then the particulate emission should not be very large, as these are the heavy, as we are moving towards, now we are moving towards the heavier cuts. So the impurities will be higher in these heavier fuels, in this residual fuel. That is, the amount of sulfur, amount of nitrogen, then metal traces will be much higher compared to the lighter cuts. So particulate emission should be there, but it should be minimized. Then carbon to hydrogen ratio. Oh, similarly, in the heavier cuts, the carbon amount is much higher compared to hydrogen. So carbon hydrogen ratio is higher uh, in these residual fuels. And sulfur content is comparatively higher in these fuel oils compared to the lighter cuts. And the flash point should be high to prevent uh, uh, mean any fire hazard. Coming into the storage tank in residual fuels are generally made of mild steel as vertical and horizontal cylinders. Safety regulations for this type of fuels are generally relaxed, that is not highly flammable due to low volatility. As they are heavier residual cuts, so their volatility is not very high, so due to which they are not very highly flammable. So they mainly come under the safer fuels. Due to high viscosity of the fuel, the storage temperature must be controlled in order to keep the viscosity low for pumping. Mean as they are high, as they are residual fuel, so their viscosity is very high. But if they are used in the burners and engines, they should be pumped. They should be able to pump. So for that purpose, they are stored at a temperature, at a higher temperature, at a temperature at which it becomes easier for their viscosity becomes as low enough for easy pumping. The bulk temperature, it is kept at 10 degrees C above the pour point of the fuel. If during the bulk storage, the temperature should is kept 10% higher than the pour point. Obviously, should be higher than the pour point. Otherwise, if not, it will not flow and it will not be easily pumped. Temperature at the strainers and filters at the pump maintained at a lower level, which is necessary for efficient pumping. Next cut is the lubricating oil, which is the heavier cut. Petroleum fractions having an firstly, I would like to tell that lubricating oils are produced not from all kind of crude oils. Crude oils which are mainly loop bearing crude oil will only produce lubricating oil. Basically, we are trying to tell is the crude oil which consists of lubricating oil will only produce the lubricating oil at the as the heavier cuts in the vacuum distillation unit. If lube if lubricating oil is not present in the crude oil, in the initial crude oil, then in the vacuum distillation unit, we will not get lubricating oil. We will only get the light cycle oil and heavy cycle oil in the in the vacuum distillation unit. The petroleum fraction having an average volatility less than that of the gas oil forms the basis of various lubricating oils. its volatility is much lower compared to the gas oils. So lubricating oils are blends of lubricating oil base stock and chemical additives. Mean the we get this lubricating oil from the vacuum distillation oil from vacuum distillation unit as the side cut of the vacuum distillation unit, but it cannot be used directly as given out from the vacuum distillation unit. It is basically a blend of this lubricating oil base stock which we get from the vacuum distillation unit, side cuts of vacuum distillation unit, and chemical additives. It is a blend of both these components. Some chemical additives are added which impart enhanced desired properties to the finished product. The four most important functions that a lubricant must fulfill, it is the lubrication, that is friction and wear reduction. Lubrication is done for basically for to reduce the friction between two moving parts and to reduce the wear. And then the cooling, heat transfer by the cooling that mean during the contact of the two moving parts, there is a generation of heat. A huge amount of heat is generated, which is also cooled by using this lubricating oil. Heat transfer is done where it acts as coolant to dissipate this large amount of heat generated by the moving parts of a machine. Then cleaning and suspending, mean if during the this action of these moving parts, there is the production of some amount of impurities such as acid sludges and varnishes. Then these impurities, they are cleaned and suspended in this lubricating oil and given off out of the machine. And then protection from the rust and corrosion is also done by the lubricating oils. Different processes sequences involved in manufacture of lube oil based stock. Mean these are the different processes which are involved in the manufacture of lube oil based stock. So the first one is vacuum distillation, isolates individuals. As I told that it is the side cut gives out the vacuum distillation. Side cut from the vacuum distillation unit gives the raw lube oil fraction according to desired properties. Then the de-asphalting of vacuum residue is employed to produce a feedstock for a very heavy lube oil called bright stock. Means the vacuum after this lube oil stock from the side cut of the vacuum distillation, the lower from the bottom we get vacuum residue. This vacuum residue is also de-asphalted to produce a feedstock for a heavy lube oil called the bright stock. Then the solvent extraction process is also improve the viscosity temperature characteristics. Visco- the solvent extraction process is used to remove the lighter cuts if present in this lube oil, which also enhances its viscosity temperature characteristics. And de-waxing removes wax and improves the pour points. If some amount of wax is present in the lube oil, which will affect its pour point, that de-waxing is also done to remove that wax so that the pour point is enhanced. And finishing is done to improve its color stability, and oxidation stability. Then the synthetic base stock. These are basically these are the mineral lube oil, which is given off from the uh, crude oil. There is another kind of lube oil, which is a synthetic base stock. Base oils may also be obtained from synthetic or biological origin. So the what happens is this lube oil will it is high in demand in various industries and machineries. So but it So therefore, to meet the demands, nowadays, not only this mineral lube oils are used, some kind of synthetic lube oils are also produced. Moreover, another advantage of synthetic base stock is that they does not impose environmental issues to the, this pollution issues to the environment. That is, these mineral lube oils, when they are after the use, if they are discarded into the atmosphere, it may cause pollution. It may cause pollution issues. Whereas in the case of this synthetic waste stocks, they are mainly biological. They are mainly made from the biological origin, which makes them biodegradable in nature. So the synthetic base stocks are manufactured through chemical transformation of petroleum derived organic chemicals. So some petroleum, how they are made, there are two methods of making. One is the some petroleum derived organic chemicals such as polyalpha olefin and polyalkyline glycol. These chemicals are chemically transformed to produce synthetic base stock, and these base stocks, though expensive, are the only choices for extremely demanding applications where mineral oils cannot be used. So these lube oil based stock, which we were talking before, were the mineral oil based lube oil, and now we are talking about the synthetic base stock. Sometimes no, it is not like some most of the sometimes a mixture of this synthetic base stock and the mineral base stock is also mineral oils are also used. Blended base stock mixture of synthetic base stock and mineral oils are often used to benefit from superior low temperature properties, high flash points, and high viscosity index at a low cost. Base stock of biological origins also are also gaining interest nowadays, which includes vegetable oils, which are obtained from seeds and fruits. Why they are becoming very important? Because gaining interest because they are highly biodegradable in nature and non-petroleum origin. They are becoming increasingly important. Coming on to some of the additives which are used in the lubricating oil. Additives to improve the viscosity index are added so that the by increasing so that at a very high temperature, when they are used in a condition in extreme high temperature conditions, it should not the viscosity of the lubricating oil should not change. It should not be the viscosity should not be affected much. To increase the oxidation stability, antioxidants are added so that it may retard the formation of hydrogen peroxide. Hydrogen peroxide in the lube oil when it comes in contact with the with the atmospheric air, which are the main cause for the oxidation of the lube oil. This lube oil some kind of additives are added so that this lube oil keeps all the contaminants, which contaminants are formed by the moving parts of the machine. If for example some acid sludges or varnishes, if they are given out, so these contaminants it can form a suspension with the lubricating oil and can be given out of the moving parts. And then these additives to reduce the friction. Then these additives also prevent wear through neutralization of acid derived from fuel combustion. In the engine during the combustion of the fuel, if there is the emission of sulfur dioxide, which in contact with some amount of moisture inside the engine, it may form sulfurous acid, and this acid may cause the wear of the engine. So to neutralize this acid also, sometimes lubricating oil helps, and to prevent and after so the neutralization of the acid is done by these lubricating oils, and which in turn prevents the wearing of the engine. And to 4-point depressants are added for easy portability of the lubricating oil. Then rusting anti to prevent rusting and foaming also additives are added. Typical lubricant composition. Coming on to the typical lubricant composition of a formulated lubricant comprises of a base fluid. As we can see, from 70 to 95% of base oil is used, and then some amount of performance package is used, that is 2 to 30%, and viscosity modifiers are used. So what is this This is the base oil which is present in all the oils. Along with that, performance package is used, which differs from application to application. Depending on what kind of application our lubricant oil will be used, this performance package varies. So these are the list of the performance package for the emulsifiers and demulsifiers, foam inhibitors, friction modifiers, pore point depressant, and viscosity modifiers. These are basically physical. They basically affect the lube oil physically. Mean no chemical changes takes place. They are basically chemically inert. Whereas the oxidation inhibitors and corrosion inhibitors, they are chemically active. They perform some kind of reaction inside the lubricating oil to prevent oxidation of the lubricating oil and to prevent corrosion and rusting. Coming on to re-refining of used lube oil, as I told that the discarding of single-use lube oil into the atmosphere, there are two problems. That is, it creates environmental issues. Moreover, it is not feasible to use it single time and discard it. Therefore, the procedure, what is done, the after using of the lube oil, once it is redefined to produce a recycled version of it and to use it again for numerous times until it is completely exhausted. So redefining of used lube oil is an economically attractive recycling method in terms of resource conservation and environmental protection. It allows processing of hazardous materials in a safe and effective way to recover a high quality oil product. This results in a strong economic incentive for re-refining considering oil prices. As we know that the oil pricing is increasing day by day and its refining is and quantity of oil beneath the earth is also decreasing. Therefore, throwing it away after a single use is not feasible and it gives a very strong incentive for re-refining of the a very strong reason for us to re-refine used lube oil. Used lube oil is generally a mixture of different types and grades of used lube oils coming from motor crankcases and industrial users. And basically, the efficiency of used lube oil, it is 2 liters of used lube oil gives about 1.5 liter of re-refined oil, which is quite feasible, as we can see. Coming on to the life lube oil life cycle. Basically, lube oil production first time, then it is sent to the market for marketing, and then lube oil is used, and the used lube oil is given off, and it is collected, and it is sent to the refining unit where it is refined and sent back to the. After refining, it is sent for refining. After refining, it is again sent to the lube oil marketing. So this cycle goes on until our lube oil is completely exhausted, and its further refining becomes economically uh, inefficient. Coming on to the advantages of re-refining of lube oil, one advantage is the environmental protection. Throwing off the single-use lube oil, it is not economically, it is not feasible. Moreover, it creates environmental issues, environmental hazards. The second one is energy consumption during the production of during the re-refining of lube oil is quite low compared to the production of virgin base oil. Therefore, it is also another reason. And the third one is high quality products and less dependence on imported oil. Mean the after the re-refining of lube oil, it the quality of the product is very good. Therefore, we less dependency is done. Mean less dependency on imported oil. Main step of re-refining. These are the steps of re-refining. Used lube oil is collected and stored, and then it is sent to the pre-treatment where filtration, centrifugation, decantation, and sedimentation is done, which are to remove the physical impure. Particular. Sorry, which removes particulate impurities. Further heating is done to improve its flowability so that it can be easily given off, pumped into the next stage, pumped up for the next stage. There is the regeneration. by treatment with acid, caustic, then active carbon, clay, and solvent extraction is done. Here, chemical impurities are removed. Then, after this chemical impurities removal, after this acid treatment, all these treatments, it is sent to the base fractionation where distillation takes place in the either in the vacuum distillation chamber or both in the vacuum and atmospheric distillation chamber to further remove the lighter ends from it, and the final product, that is the finished purified product, is sent for finishing where adsorption, neutralization, decanting, and filtration takes place, and we get a refined oil, and along after that some additives are added to it to give us our new refined lube oil. Coming on to the next product, which is the engine lubricant or the motor oil. Engine lubricant is used for lubrication of internal combustion engines. So the main function of motor oil is to reduce the friction and wear on the moving parts and to clean the engine from sludge. It also sometimes, as I told, in the engine during the combustion, if sulfur dioxide is emitted out due to the presence of sulfur content, and this sulfur dioxide in the presence of some amount of moisture, if there is some moisture inside the engine, it forms sulfurous acid, which may cause the corrosion of the engine. Therefore, this motor oil, it also neutralizes this acid that originates from the fuel and from oxidation of the lubricant, and it also improves the sealing of piston rings and cools the engine by carrying heat away from the moving parts. For effective operation of IC engine requires efficient sealing between the piston and cylinder liner. For the sealing between the piston and cylinder liner, this motor oil helps. And in addition, the lubricant is the prime source of cooling of the piston cylinder arrangement. And it also acts to prevent deposits on the operating surfaces, thus prevents leakage. Coming on to the next product, which is the industrial lubricating oil. That is, the industrial lubricants are basically defined as compounds like fluids, grease, and oils. They are used in order to lessen wear and tear of materials while reducing binding and friction. It is mainly used in the industries in between the moving parts of the two moving parts of the heavy machinery used in the industries. So main function is to lessen the wear and tear between the two moving parts and to reduce the friction. Industrial lubricants are reliable because they have the capacity to provide heat stability, and they mean these industrial machines, these heavy machinery, they work at a very high temperature. These two moving parts, they generate huge amount of heat. So this lubricating oil, industrial lubricating oil, it should be stable even at high temperature ranges without breaking down. So that is the main property which is required in this industrial lubricating oil. That is, it should not break at high temperature ranges. From gear oils to greases, the standard and high performance lubricants can help the necessary equipment to run smoothly even in the most difficult environments and for a long period of time, ensuring the quality and sustainability. In these oils, they helps in the easy and smooth running of this machinery without breaking down. Light grade of lube oils are having viscosities of 5.5 to 12.5 centistrokes at 60 degrees C. The next is hydraulic oil, which is the hydraulic lubricant. It is used to transfer power in hydraulic systems. It provides satisfactory lubrication performance in the various items and equipments, including hydraulic systems such as brakes, elevators, or excavators, and improve pumping efficiency. So this hydraulic oil is used. It is used in the hydraulic systems to transfer power and to improve the pump efficiency. Then coming on to the turbine oil, which is the turbines. They are the primary equipments for generating electricity. So in turbines, the lubricant must provide a hydraulic oil film that supports the shaft and cools the bearing. It is mainly this turbine oil is used for cooling of the bearings and to support the shaft. And one of the key requirement of the turbine oil is the long life. At least up to 10 years long life should be there of the turbine oil. Turbine oils are a mixture of base oil, corrosion inhibitors, oxidation inhibitors, defoamants, and demulsifiers. Coming on to the gear oils, the main function of gear oil is to lubricate the critical contact of the gear teeth and associated bearings. It is basically gear oil is used to lubricate the contact point of two teeth of the teeth of two different gears and associated bearings. It cools the gear and gearbox and protects the parts against corrosion and reduces energy losses. The gear oil is made up of two critical components: base oil and additives. Means as most of the lubricating oils, it is also consisting of a base oil and some additives. The gear oil must remain thermally stable and not oxidize at high temperature, thus avoiding the creation of sludge or varnish. So the main requirement of gear oil is that it should be stable at high temperature and it should not oxidize. Gear oil must fight contamination that enters the system, especially water. The oil must be able to demulsify, which allows for easy removal of the water from the gear. So some demulsifier agents are also used so that if entry of some amount of water takes place into the gear system, then this gear oil also easily demulsify and removes this water which has entered into the gearbox. Then the fluids are essentially the type of fluids which are generally used while cutting operation takes place. It is primarily applied in machining tasks which can be anything including drilling, milling, cutting and turning. So where drilling, milling or cutting kind of actions takes place, there this cutting fluid is used. It is also referred to as coolant. Main function of this fluid is for cooling purpose and lubricating purpose because it is used to reduce the heat generated during the metalworking operations, or in other words, to cool the cutting tools. Mean it is mainly to provide lubrication between the two cutting parts and to cool the heat. Dissipate the heat generated during the cutting. This reduces cutting force and torque and prevents the chip and tool from welding. Sometimes due to this huge amount of heat generated during this cutting, the chip and the tool parts may also weld. So it also prevents from that. The two main categories of cutting fluid. One is the oil-based cutting fluid, and other is the water-based cutting fluid. Coming on to the quenching oil is used for the fast cooling of steel during steel manufacture. A fast, in the steel manufacturing industry, where fast cooling of steel, heating and fast cooling of steel takes place, there this quenching oil is used. Fast cooling gives the hardest form of steel, that is martensite. So therefore, the fast cooling of the hot steel is very necessary for that purpose. As this quenching oil is used, quenching oils are heat treatment oils blended from solvent refined base oils with specially selected additives that facilitate fast quenching through proper and controlled cooling and have outstanding chemical and oxidation stability. So mainly quenching oils, they are basically a mixture of different oils and additives. The additives which enables the fast as well as controlled cooling of uh, hot steel and also prevent chemical and also prevent oxidation of the steel. So the quenching oils also have excellent thermal properties, low volatility, and high flash and fire point. High flash and fire point. Why? Because this very hot steel is immersed into this quenching oil for heat treatment. So if the oil itself will have lower fire and flash point, then fire hazards may take place. Quenching oil trends are to use water miscibility products such as alkylene glycols to produce required cooling temperature. Now coming on to the next product, which is the jute batching oil. So jute batching oil, it is a middle distillate product which is produced from the petroleum refineries. It is basically produced in the atmospheric distillation unit between the kerosene and diesel oil. Kerosene, then jute batching oil, and the diesel oil, and it is sometimes mixed with some parts of diesel oil also. It is mixed along with it. So, jute batching oil is obtained as a straight run product from distillation of crude oil in the petroleum refinery during twisting. So where it is used, where it is mainly produced in the areas where jute industries are there, where jute work is done. So in those areas, if there is a refinery, then this jute batching oil is produced in those refineries only. It is not like in all the refineries, this oil is not produced. So where it is used during the twisting and weaving of jute threads, oil is invariably used as lubricant for easy segregation of the jute fiber. The oil needed to be combined with emulsifier prior to using. Some additives are also added in this oil before using it in the jute fiber processing. That is, some emulsifiers are added. And jute batching oil is also used as a wash oil by some steel plants for recovering aromatic products from the coke oven gas. This coke oven gas, it is highly rich in aromatic products in the form of gases. So these aromatic products are sometimes removed from this coke oven gas by using this jute batching oil as wash oil in the steel plants. The next one is the white mineral oil. White mineral oils, they are manufactured from selected lubricating or base oils by either severe hydrogenation or intense acid treatment with fuming sulfuric acid. This white mineral oil, it is manufactured from the lubricating base oil. If that lubricating base oil, it is treated with, if it is either hydrogenated or acid treated, then we can get this white mineral oil. The objective of hydrogenation or acid treatment is to produce a non-reactive saturated hydrocarbon liquid. So this lubricating base oil, if suppose it may consist of diolefins or naphthenes or aromatics. So they are basically, if they are hydrogenated, then we can get non-reactive long chain saturated hydrocarbon liquids, so which comes under white mineral oil. White mineral oil, it is used mainly as plasticizer in polymer industry, then moisturizers in cosmetics, lubricants in food processing and medicinal products. For use in pharmaceuticals, cosmetics, or food applications, this white mineral oil process should be devoid of, it should be completely free from all traces of reactive compounds. Means the traces, even the traces of impurities are not acceptable in these cases. As you can know, this pharmaceutical, cosmetic, and food industry is very sensitive. And for the use in textile and adhesive applications, may use less restrictions. In this case, restrictions are very much, but in this case, it may be less. Manufacturing process of white mineral oil by acid treatment. So, firstly, acid treatment is done. During acid treatment, what happens is the production of acid takes place, which is further neutralized, and sulfonate extraction takes is further neutralized, which releases sulfonates. Means formation of sulfonates during neutralization takes place, and sulfonates are formed. So these sulfonates are further extracted by a solvent, some solvent, and then this solvent is removed and stripped to remove the light ends, and the solvent recovery and sulfonate recovery takes place. Further, after the solvent recovery and sulfonate extraction, treatment of this oil is done with clay to remove undesirable constituents such as residual moisture and trace solvents and aromatic hydrocarbons. And after that, um, sludge disposal and acid recovery. Finally, the sludge disposal and acid recovery of the oil takes place, and we get the white mineral oil. This lubricating base oil, firstly, it is treated with acids, strong acid, that is, firstly, it is treated with oleum, which releases some amount of sulfonates, suppose Na2SO3. So this Na2SO3, it is neutralized, which releases. This after treatment with acid, neutralization is done, and which releases this sulfonate, which releases some amount of sulfonate. So the sulfonate extraction is done using some solvent, and after the sulfonate extraction, the solvent is recovered along with the sulfonate. And after the sulfonate and solvent recovery, some treatment is done with clay to remove undesirable constituents, and further sludge disposal and acid recovery is done to yield the white mineral oil. The next product which we get from the crude oil is bitumen. The term bitumen is used throughout the world, but except in USA where asphalt is used instead of bitumen for the solid or semi-solid materials, which is made by processing residues obtained from refining suitable crude oil. Bitumen is mainly we get from the residues given off from the distillation unit, bottoms from the atmospheric distillation unit and vacuum distillation unit, and moreover the bottoms of different secondary distillation units. Secondary distillation units, that is the hydrocracking, catalytic cracking, and reformant, etc. Okay. So bitumen, it is mainly used as a binder and waterproofing material in road construction and to a lesser extent in roofings. Basically, mainly it is in industries for roofing purpose. Bitumen is used. Bitumen owes its widespread use to its unique viscoelastic behavior and its low cost as an engineering material. It is a heavier residue given from the crude oil, so it is not very costly as an engineering material, and it has a unique viscoelastic behavior. In order to establish the proper bitumen for its intended application, it is important to know the condition to which the bitumen is exposed. At high temperature and long loading times under the application of force, it behaves as the fluid, resulting in permanent deformation, and at low temperature and short loading it behaves as elastic solid. As it is given here, it is a viscoelastic in nature, so at higher temperature and long loading time it acts as fluid, whereas at low temperature and short loading it acts as a solid. The behavior of bitumen is defined by stiffness modulus, which is a viscoelastic modulus dependent on time and temperature, which is given by this stress strain equation. And this is the elemental composition of bitumen, which consists, as we can see, it consists of very large amount of carbon. Therefore, it is very heavy residue given from the crude oils. Next product is the petroleum wax. Most crude oils contains a certain amount of wax. As I told that if the concentration, but it that most crude oils they consist of certain amount of wax, but its concentration can vary. The main part of the petroleum wax present in crude oil boils in the same range as lube distillates. So, as I told, the lube distillates they consist of mainly uh, um saturated hydrocarbons, basically, and paraffins. So, and paraffins, isoparaffins, mainly paraffins it consists of, and lesser amount of aromatics are present. So, if and paraffins are present, if the and paraffins are higher in concentration. So directly it means it consists of large amount of wax content. So mainly crude oil which consists of lube distillate. That lube distillate consists of equal amount. I mean uniform distribution of wax throughout its cut. Throughout its cut. It is not possible to separate wax and lube oil, but therefore mean the boiling range of wax and lube oil cut is similar. Therefore, it cannot be separated. Mean it cannot be separated from distillation procedure. Therefore, solvent extraction or dewaxing methods are used. Straight chain and paraffins are chemically the simplest hydrocarbons with multi-component petroleum wax. The N paraffins with chain length of 16 to 70 carbon solidify at room temperature. Whereas if the chain length increases, the melting point further increases. Okay. Simply speaking, where there are large number of N paraffins, wax will be there. Coming on to the types of waxes, which is macro and microcrystalline waxes. The low boiling vacuum distillate consists predominantly N paraffins with slightly branched paraffins within this boiling range. Mean if the vacuum distillates, they have low boiling and paraffins. Mean if the boiling point is less, then they consist of mainly N paraffins with slight branch paraffins. Whereas if the boiling temperature increase, the distillate given out, the waxy distillate given out, it consists of mainly branched paraffins in addition to normal paraffins. Mean the branched paraffin content increases with increase in the boiling point. Okay. The paraffins with a high normal paraffin content mean waxes are mainly N paraffins. Good quality waxes are N paraffins. Some amount of isoparaffins are also, mean branch paraffins are also considered, but mainly N paraffins are considered. So if large amount of N paraffins are there, then these waxes easily crystallize to form needle-like, very organized needle-like structure. Such waxes present in the spindle oil and light machine oil distillates are called the macrocrystalline waxes. Whereas if the branched and cyclic structured paraffins are present, then then small formation of large, well-defined crystals is not crystal uh, does not take place. Small crystals of wax forms, which further agglomerate to form large crystals, and the in between those agglomerates, trap large amount of crude oil gets trapped. Okay, so the single crystal becomes smaller and agglomerate, which include significant quantity of oil present in them. Means suppose in macrocrystal these needle-like structure forms, whereas in this, suppose these are the crystals, smaller crystals form, and they agglomerate, and these spaces between them, it traps large amount of oil. These components are called the microcrystalline waxes. Coming on to the petroleum coke, another product of this crude oil, it is the petroleum coke, which is considered as a valuable solid byproduct of crude oil refining. Coking operation consists of heating the heavy oil feedstock to higher temperature, thereby cracking the oil and driving off lighter products. So, coke, as we told, it is it is mainly similar to coal, but it is hydrophobic, whereas coal is hydrophilic. Take the requirement for a petroleum coke are low sulfur, ash, and metal content. And mean if low sulfur, ash, and metal content is there, then it is used as fuel. And if low porosity, good conductivity, and low coefficient of thermal expansion is there, then it is used as electrode. Good quality of petroleum coke for electrode manufacture can be obtained from high aromatic, high molecular weight, and high molecular weight petroleum stocks. So coke, it has a very good calorific value of around 7,500 kilocalorie per kg compared to coal, which has about 4,500 kilocalorie per kg. So this is used as fuel in most of the case nowadays. As coal, it also absorbs moisture, whereas coke does not absorb moisture as it is hydrophobic. So coke is a better fuel compared to coal. These are some of the properties of petroleum coke. The physical properties of petroleum coke are determined by type of coking process used, then feedstock properties, and the coking operation condition. Petroleum coke is a dark gray or black infusible solid that can go through a plastic stage at a higher temperature of 1500 degrees C. It is insoluble in water. As I told, it is hydrophobic, which becomes a very good quality as a fuel. Then density of petroleum coke is 830 kg per meter cube. Then carbon is the main chemical constituent of petroleum coke, and petroleum coke also contain minute traces of metals such as silicon, iron, vanadium, magnesium, manganese, sodium, and calcium. Under normal conditions, petroleum coke is stable and non-reactive and does not polymerize. Combustion of petroleum coke produces oxides of sulfur and carbon. Incomplete combustion generates, sometimes it generates carbon monoxide also. Coming on to the applications of petroleum coke. So, petroleum coke is used in two ways, one as fuel, another as electrode material, as carbon source. So, it is used as fuel for the production of cement, then in lime kilns, then gasification units and industrial boilers, and further as carbon source, it is used in electrodes for electrometallurgical industries, in synthetic graphite, aluminum anodes, TiO2 pigments and carbon razor, silicon carbide foundries, and coke oven. Now coming on to the assignment questions. Coming on to the first question, am I audible? Hello. The first question, which is the refinery operation, which is not a source of production of liquefied petroleum gas, is. So the answer to this question is vacuum distillation unit. In the vacuum distillation unit, the production of LPG, no LPG is produced. Whereas in the case of atmospheric distillation unit, in the overhead it gives LPG, whereas the today's catalytic cracking and visbreaking also the overhead gases may consist of some amount of propane and butane, which is mainly the composition of LPG. Coming on to the next question, which is the Marox treatment of LPG is done in the refinery to remove. The answer to this question is Marox treatment, and all those treatments were done to remove sulfur compounds. Mainly the sulfur compound should be removed from the LPG. So for that purpose, Marox treatment is done. Third question is which component in gasoline among the following ones is not objectionable? So the in gasoline objectionable components, let us first talk about the objectionable components. The first one is benzene. As I told, it is carcinogenic, so it is highly objectionable. Then metal contents are also objectionable because it may form, it may deposit on the inside the engine. It may cause corrosion of the engine. Then sulfur content also leads to the emission of SO2 and different harmful gases. For that purpose, it is also objectionable. Only isoparaffins, they are not objectionable in the case of gasoline. Fourth question, which is what is middle distillate? As I told, middle distillate, it indicates both the presence of both the combined cut of kerosene and diesel is called the middle distillate. It is collectively called middle distillate. Cutter stock, which is used to blend with the residue, is called. In the fuel oil, we studied about it that fuel oil is heavy residual oil. So to improve its quality, we need to blend it with some lighter fractions. So the lighter fraction which is used for the blending is called the cutter stock. So basically, the cutter stock here is the gas oil. Coming on to the sixth question, that is the application of lubricating oil additives in lube oil is. So main aim of lubricating oil, main property of lubricating oil, as I told earlier, is the viscosity index. Viscosity index is one of the most crucial property of lubricating oil. So the main property here, the main additive which we cannot omit is the to improve main additive is to improve the viscosity index. Question number 7. Pick the correct statement. Jute batching oil. First question: Jute batching oil is obtained from cracking unit. No, it is not obtained from the cracking unit. It is obtained from the atmospheric distillation column. The second question, second option: bitumen should have good viscoelastic properties. Yes, this is correct. As I told, bitumen is a bitumen shows viscoelastic nature. So this is correct. Coming to the third one, which is white mineral oil is manufactured by blending gasoline with diesel. No, it is done by acid treatment, hydrogenation and acid treatment of lubricating waste stock. And petroleum wax is majorly a mixture of aromatic and naphthenic compounds. No, it is basically mainly it consists of the and paraffins and some amount of iso and branch paraffins as well. So these three are wrong options. This one is the correct option. That is the bitumen should have good viscoelastic properties. Coming on to the next question, which is one of the main functions of gas oil is. The answer to this is gas oil. It is used to resist corrosion. I mean, the along with the additives, it is used to resist corrosion to the metal surfaces. Coming on to the ninth question, which is the jute batching oil is obtained from the following unit of refinery. As I told, it is obtained between the kerosene and diesel cut, jute batching oil and diesel cut in the atmospheric distillation unit. That so the answer is atmospheric distillation unit. The major component, last question, that is the major component of petroleum wax is. As I told, the petroleum wax, it consists of mainly N paraffins along with some amount of branch paraffins. So the answer to this is N paraffins. So we are done for today. Thank you for your patience. Okay, let me end the class.